Welcome back. So today we continue solving questions on functions. Okay, so last time we gave brief introduction. Today we solve more questions on functions. So we have f and g. This is a question, this from past question, are defined over R as f of x maps to 2x squared minus x, and g of x maps to 7x minus 6 all divided by x, where x is not equal to 0. Now there are new things that we see here that I didn't mention. I will explain them in a moment. If f of a is equal to g of a, find a, and b, find the inverse of g, and c, find f of g of 2. Okay, let's do this. Okay, so f and g are defined over R of real numbers. So the thing to keep in mind is that normally R, and by the way, when it's printed on the paper, it will be deepened, it will be darkened like this, it will be in bold. R. This always represents the set of all real numbers. And by real numbers, just think of it as all numbers that make sense, right? All numbers that make sense. All numbers. I don't want to introduce you to complex numbers, but then they are a thing. So every real number that is not a complex number, and complex numbers, you will find them with i's written besides them like this. So since you practically would not be dealing with such kinds of numbers at this level, there's no point in really going any further mentioning it. So whenever you see R, or they tell you something is defined based on the set R, or when you say anything about the set R, just bear in mind that it means all numbers that you know at this point. Okay, so what they mean is that, remember in previous questions, the domain is usually limited. So the other one gave -3, -2, -1, 0, 1, 2, 3. But for this, they are saying that all real numbers are. So meaning it's 0, 1, 2, 3. In fact, and everything between. So it will be 0.11111, all of the fractions in between, right? 0.0001, 1/2, and so on and so forth. Every single thing, all numbers that we know at this point in time. Okay, so that's what they mean by defining the two functions over that particular R. So, and then they now told us what those functions are. F of x is 2x squared minus x, and g of x, of course, is 7x minus 6 over x. But here they now said something peculiar. X is not equal to 0. Why must they say that? Well, first of all, take g of x. If you put x equal to 0, what do you get? You get 7 times 0 minus 6 divided by 0. This becomes 1 divided by 0. This is a nonsensical value. Nonsense is undefined. You can't divide a number by 0, not even 0 by 0, alright? Or 1000 by 0. It just doesn't make any sense. You can try it on your calculator and see what happens. Okay? So that is why they give that disclaimer. So this function, no, they're actually talking about it. This function is true as long as x is not equal to 0. This function exists as long as x is not equal to 0. And you realize that when you substitute x equal to 0, it gives you a number that doesn't exist, which is undefined. Okay. So now that we have that out of it, and by the way, in future we'll be, actually very soon, we'll be solving questions that requires us to find the number that will make a function undefined. Okay. So in this particular case, they already did that and they found that 0 will make this function undefined. So they are telling us that we shouldn't substitute 0 here, otherwise we'll get an undefined. Right? Okay. So let's go ahead and solve this question. Let's start. Yeah. Alright. So if f of a is equal to g of a, that means there is a number that whether you substitute it in f of x or g of x, you get the same exact answer. Okay, so let's just go ahead and do that. So f of a is 2a squared. We're substituting a here, minus a equals g of a. So we substitute a here as well. 7a minus 6 divided by a. Alright, so we solve for a. So we can first multiply through to get 2a squared minus a all times a equals 7a minus 6. Okay, that is one way of doing this. Okay, so we multiply this to 2a cubed minus a squared equals 7a minus 6. Now this looks like a cubic function, right? So this gives a cubed minus a squared. No. So we basically bring this in. Minus 7a plus 6 equals 0. And now we solve this like a cubic expression. There's a cubic expression or cubic function. Now, in future, when we tackle polynomial functions, I will solve questions on how to answer, on how to solve these manually. But for now, I'm just going to use a calculator to find the value of a, the values of a. Now, the rule for these polynomial functions is that the highest power of the variable, the highest power represents the number of possible answers, the number of possible values of a that satisfy this equation. Alright, so that means there are 3 values a can take to satisfy this equation. Okay, so if you use your calculator to find this, you'll find that the first answer will be 3 over 2. And it can also be minus 2 and minus 1. You realize that if you substitute any of these into the equation, you get 0. Okay, so these are the values that a can take. Yes, and yeah, this is really the crux of it. Elective mathematics usually, requires you to have understanding of all the different topics, because one question will many times require that you understand concepts from other topics. So you must take note of that. Okay, so that's how we find a. If you want to know how this is done, we will publish our tutorial on polynomial functions very soon. Okay, so let's go ahead and solve the next question. Okay, so B says find the inverse of G. So we have to find G inverse. Okay, now G of x is given to be 7x minus 6 divided by x. So what does it mean to find G inverse? Let me just quickly explain it. Remember I said a function can be thought of as a machine. Let me just change my drawing of a machine. This looks like a boat. Initially I was drawing and then it seems I was going to draw a comb and then I decided to just do anything. Sorry. So let's call this G of x. Anytime it takes x, it brings out a value this way, right? Changes it to that. And then whatever this gives, it will, to bring it out, right? Now the inverse of g of x is a function that takes whatever g of x brings and change it back to x, right? So maybe something like this. It basically undoes what g did. So we call this g inverse of x. It takes this and then undoes it and bring back x. So that is the meaning of finding the inverse of x. For example, before we actually solve the question, let me just give you a simple scenario. Okay. All right. So let's say f of x is equal to x squared. So f of x, this takes a value x and then squares it. If I want to reverse this, I have to take whatever x squared is and then find the square root, and this will give me back x. So this gives back x. If I put it in this function, it squares it. If I bring it back into this function, f inverse of x, it finds the square root and brings back x. So f inverse of x is square root of x is the inverse of f of x, which of course is equal to x squared. You can see clearly that they are actually inverses. This does the opposite of this. Okay, so that's what we need to find for g inverse, for g of x. So now there's a neat little way of finding it. Okay, so first we say let y equals 7x minus 6 divided by x. So of course, when you evaluate this expression given x, it will give you some value y. That's what we are saying. So let y, some value, be the value that you get whenever you substitute the x in here. Okay. So what we do is we make x the subject. You find that when we make x the subject, we are we're trying to find the expression that will give us the original x. The original x that was put in the function g of x. So that's basically what we do. So we make x the subject to find the original x value. Remember, the inverse function is trying to look for the original variable that was put in the function. So we make x the subject from here. So first we cross multiply to get xy equals 7x minus 6. Then we gather like terms, xy minus 7x equals minus 6. And then we factorize x out to get x outside, and y minus 7 equals minus 6. You can divide 2 by y minus 7, and so we find that x equals minus 6 divided by y minus 7. Now we are not done yet, but then you realize that this means that to get back x, you need to take the result from g of x and then you put it in this expression. If you put it here, you get back x. So since this particular function, this particular expression undoes, since it undoes the job of g of x, we now call this g inverse of x. But you see, we are writing it in this way, g inverse of x, meaning it should also take x. So of course we have to make sure that the variable here is x. So we just say minus 6 divided by x minus 7. So this is g inverse of x. Alright? Remember, if I were going to leave it as y, then I probably should have said g inverse of y equals minus 6 divided by y minus 7. Alright? Okay. So this is how to find g of x. But then this way that I've done it is what's, for the most part, is what they expect you to do, so that you don't get any problems. Alright, so this is how to find the inverse of a function. We will do more questions. Alright. In fact, let us actually solve more questions on that before I tackle the composite functions. So we will come back to the last question. So let us solve a little more on finding inverses. So again, we have f and g. Sorry, f and g are functions on the set of real numbers, such that, remember, in this question they just say set of real numbers. Sometimes they will use R in the set R of real numbers, such that f of x maps to 2x minus 3 divided by x, where x is not equal to 0. You can see the same thing I said last time. And g of x maps to 1 minus 3 over 2x. So we have to find f inverse and g inverse. They actually added something. They said find this stating the largest, their largest domains. Okay. All right, so let's do this. So again, we have to find the inverse of both f of x and also the inverse of g of x. So f of x is equal to 2x minus 3 over x. Alright? So again, to find the inverse, let's y equals 2x minus 3 over x. Okay, so this is the value that what f of x will give when you put x in it. It does this and brings out y. So to find the inverse, we make x the subject from here. So from here, we first cross multiply xy equals 2x minus 3. Then we gather like terms, xy minus 2x equals minus 3. And we factorize x out, equals minus 3. And then we divide through by this. And so x equals minus 3 divided by y minus 2. So therefore, the inverse of x, f inverse of x is equal to minus 3 divided by x minus 2. Remember, we just change this to x. And that's it. So this is the inverse of f of x. So f inverse of x, like that. Now, the largest possible domain. In fact, before that, let me just write f inverse of x is equal to minus 3 divided by x minus 2. So let us keep this down, right? When we finish we will come back and find the largest domains. Now let's find G inverse of X. Let's find G inverse of X right now. Okay, so G of X is giving us 1 minus 3 divided by 2x. So again, let y equals 1 minus 3 divided by 2x. Now we make x the subject from here. So we basically just, of course, we can first try to do away with 2, with the denominator 2 here. So this gives 2y equals 2 minus 3x. Thus we multiply each term by 2. Okay. Alright, now we make 3x the subject. So this gives 3x equals 2 minus 2y. Okay, and so we divide 2 by 3. So x equals 2 minus 2y divided by 3. Therefore, G inverse of x equals 2 minus 2x over 3. So this is 2 minus 2x over 3. Now, there's one other thing. You can actually verify whether your inverse is right or wrong. And I'll just show you that before I show you how to find the largest possible domain. So you can do a quick check to see if your inverses are correct. So for instance, f of 2, right? When you have f of 2, let's substitute x to be 2. F of 2. This gives 2 times 2 minus 3 divided by 2. And this gives 4 minus 3, 1. 1 divided by 2. Now if we substitute this into f inverse of x, we must get back the 2. So that means f inverse of half must be equal to 2. So let's do that and see. This is f inverse of x. So we have minus 3 divided by half minus 2, right? So this gives minus 3 divided by half minus 2 gives what? If this gives negative 1.5, right? Yeah, negative 3 divided by 2. You can check this out and see. Okay, so this is the same as minus 6 divided by minus 3. So this cancels out 3 here and 3 there, 2. So this gives 2. And you see that it gives back the original x value we substituted. So this proves that this is the inverse of that. You can also verify this on your own. Okay, now let's go ahead and find the largest possible domain. Okay. All right. So now, the domain, what's the domain of a particular function, right? Remember when we were mapping, right? For instance, they said, in fact, let me just use this. The function f of x said 2x minus 3 divided by x. And they gave a disclaimer and said x must not be equal to 0. This is because when x is equal to 0, this whole expression becomes a number divided by 0. And I told you that is undefined. That is an undefined value. It doesn't exist. You cannot have a number divided by 0. Okay. So, if x cannot be 0, what values can it be? Right? Well, the thing is, it can actually be any other value. Any value in the real number. So we can say that x is such that x is a member of x belongs to all real numbers, the set of all real numbers, except, or we can just say, we can just use this x not equal to 0. Remember, R is all real numbers. So what this statement means that x can take on any value in the set of real numbers. The only problem is it cannot be 0. Otherwise, it will make this undefined. Now, how do you, so whenever you are going to actually determine the domain of a particular function, first of all, you have to ask yourself what values will make this particular expression undefined. So these are the hints. 1, whenever there's a fraction, the denominator must never be 0. This is very important, because if it is 0, it will make it undefined. Okay, so whenever there's a fraction, that should be the first thing you should be doing. You should look for the value of the variable that can make that denominator 0. If there's a value that can make it 0, then when you are writing out your set of your domain, you have to make that exception. Actually, right here you can actually write except, so just the semicolon, but then this also works. The second thing to also consider is when there's a square root, not just square root, any even root, right? So it could be square root, it could be the 4th root, 6th root, 8th root, and so on and so forth. Why is that? I'll tell you in a second. So let's say you have root 4. This gives 2, right? Yeah, no problems. What if you have root 1? This gives 1. Root 0 gives 0. What about root -1? And that's a problem. If you try it on your calculator, you'll see that it will bring you an error. That is because this is not a real number. Not a real number. So that is actually the second thing you will look at. You have to make sure that whenever there's a square root, the number inside the root must never be negative. So the number inside a square root must never be negative. Is that clear? Okay. So now that we have that, let's solve the question. So what is we're trying to find the domain of f inverse of x, which is -3 divided by x minus 2. So now here there's a fraction, right? So we see that there is actually a fraction. So we look at the denominator. What value of x will make the denominator 0? Well, we can just find that out. X minus 2 equal to 0. When we make x a subject, we get x is equal to 2. So that means when x equals 2, the denominator equals 0. And that's the only situation that can make the expression undefined, right? Because there's no square root and there's no other fraction. So therefore, the domain is the set of all real numbers, because apart from 2, x can be any other value. If x is 3, the denominator becomes 1 and you can have 3 minus 1. If x is minus 1, the denominator becomes minus 3. Then you can have 1, and so on and so forth. So the domain is a set of all values of x, such that x is from the set of all real numbers, except x equal to. You see? Except x equal to. If you are not bringing the except, remember that the way you write it will be slightly different. It will look like this. X is not equal to 2. And this defines the domain of f inverse of x. Okay? Let's do the same for g inverse of x. You can rewind it as much as you can in order to understand it. If you still don't get anything, just leave your questions below. I will try to get to you. Okay. So g inverse of x is given by 2 minus 2x divided by 3. Now with this, there's a fraction which has a denominator which is just 3. Ask yourself, what value of x makes the denominator 0? Actually, there is none, because x is not part of the denominator. So this x cannot influence the denominator in any way. So based on this, x can actually be any value, because the denominator is a constant, right? So with this, since x can be any value, the domain of g inverse of x is the set of all values of x such that x belongs to the set of all real numbers, and that's it. This is the domain of g inverse of x. I hope that is clear. Let's do a couple more. Okay. So I'm going to clean the board. So now here we have state the domains and inverses of the following. We have 1, f of x maps to 3x minus 2 divided by x plus 4. 2, f of x maps to 5x plus 7 divided by 3x plus 2. 3, well, g of x maps to 2x divided by 1 minus x. And 4, g of x maps to 3x plus 2 divided by 2. I will do the first two and then leave the last two for you to try. If you don't get anything, you can just leave your questions and comments below. So domains of this. So the first one, what do you think the domain of this will be? Again, we are by looking for domain means what values can x take? What are the possible values of x that can be substituted into this function to get a real number? Okay, to get a real number. So that's the meaning of that's really what they mean by stating the domain. They want you to find all possible values of x that can be substituted into the function to obtain a real number. Now we see that there is a fraction there, and x is part of the fraction. So first of all, we look for the value that will make the denominator 0. And know that when the denominator is 0, the function becomes undefined. So therefore, when we define the domain, we exclude that value. So x plus 4, we try to find the value of x that will make x plus 4, the denominator, equal to 0. Find that x equal to minus 4. So therefore, the domain of f of x is given by the set of x such that x is a real number, but x is not equal to minus 4. Okay, now let's find the inverse. I'm just going to do it all within here, and I'm going to be a little faster. Okay, so what will be the inverse of f of x? Again, f of x equals 3x minus 2 divided by x plus 4. It's 3 right here. So let y be the value that you get when you put x into the function, which is 3x minus 2 divided by x plus 4. Okay, so now we make x the subject from this. So we have xy plus 4y, I'm cross multiplying, must be equal to 3x minus 2. I gather like terms, so I bring in the x value here and send the y value down. So I get xy minus 3x equals minus 2 minus 4y. I factorize x out. This gives x out y minus 3. And this is equal to minus 2 minus 4y. I can divide 2 by y minus 3. Y minus 3. And so x is equal to minus 2 minus 4y divided by y minus 3. And therefore, f inverse of x is equal to minus 2 minus 4x divided by x minus 3. And so this is the inverse of the function f of x. I hope this is clear. Let's do that for the second question, and then, like I said, you try the others, and then if you can give me feedback, that would be great. If you have questions and comments, you leave them below. So this time f of x is equal to 5x plus 7 divided by 3x plus 2. What value of the denominator will make, what value of x will make the denominator equal to 0? Because when a denominator equals 0, it makes the entire expression undefined. So we find that 3x plus 2 equals 0, 3x equals minus 2, x equals minus 2 divided by 3. So when x is equal to minus 2 divided by 3, minus 2 over 3, then the expression becomes undefined. Therefore, the domain is given by the set of all values of x such that x is a real number, but x is not equal to minus 2 over 3. So if you have any questions and comments, put them below. Otherwise, till next time.